Okay, so we'll start with our very first example, which I'm calling generics method. What is generics? Generics basically allow you to create a template class. This template class can then serve as many classes during runtime. So probably if you have a class that you want to treat as an integer class, and then you want to also treat that class as a double class, and you also want to treat that class as a character class, because the functionality is exactly the same. What is different between the different implementations is the data type. That's about it. So instead of creating 3 or 4 different classes, you can just create one class and on the fly change its data type. And that's the beauty of generics, pretty much, that it allows you to change the data type on the fly. And it all happens during runtime. So it's a great example of polymorphic behavior. So to get started, let's create a method. Public static void print array. Then I'm going to change this method into a generic method. Okay, is everybody done with this much?
Yep.
Now to create a generic type, first of all, you need to tell the method that I will be introducing a generic type. You can just call it any letter. I'm calling it E. So public static, this basically tells the method that there will be some type that will be figured out during runtime. And whatever that type is, E will then represent that type. The next thing is you're saying that I will be receiving an array of that type, whatever that type is. The name of that array will be elements. So during runtime, E will change to a type, which is included in the call. Then I would like to extract from this array one element at a time. So I will use my enhanced for loop, which will go into elements and will extract one element out of one element at a time into element from elements. And I can then display it. So all this method does, it receives an array and it displays it, one item at a time. Okay. Did everybody understand what I did in the method?
So you created a method of array that is a generic type, and for each element in elements, you're going to print element.
Right. And the data type of E will be determined during runtime on calls. So E can behave integer in one call. So the array will be the array of integers. In the next call, the E could be a string. So the entire array, wherever the E is, will be treated as string type. So on every call, it is capable of changing its data type. So we will start with two arrays. One is of type integer, the other one is of type character. So as you can see, there are different types. And I can even notify the user.
So I remember seeing part of this in the somewhere. The reason string is always capitalized as a data type, and the reason that integer and char normally aren't, but why are they fully spelled out with capital first letters?
Okay, let's go back to Java 1 for that.
Yep. Cool, yep.
For every primitive type, we have a wrapper class.
Yeah, sorry, I recognized it, but I couldn't place it in my head.
It's okay. So when the first call takes place, which is this call, to the print array, elements receives an array of type integer. So wherever the E is, it will act like an integer. In the next call, wherever the E is, it will act like character. And you just need one method to print both, and they both will be printed. So this is just an example to show you that you can write only one method that can do a million things for you on the fly.
This is so convenient. Like, I just want to point that out. That's amazing.
So this helps you from having to write different method just because you want to print different types. Let me know when you guys are done, and then we will move on to generic classes that you can actually create an entire class with generic types. So certain components of that class will be decided only during runtime. The other components will be fixed. So for that, let's create our next class. I'll call generics 1. Typically, when you are creating a generics class, you need to tell at the class level that, you know what, this class will receive some type. That type is undetermined right now at this point. And again, it could be any letter. However, when you receive that type, I want the property ID of the class to be treated of that type, whatever that type is.
This is insane. So that represents data type?
The T will be the runtime data type.
Wow.
So I could treat For example, ID sometimes as integer, I could treat it other times as a string. Depending on what data type I pass.
You're blowing our minds at like 8
This
a.m.
is like so cool, dude. I can't even tell you how cool this is.
We're very excited.
That's good. That's good. Good to be excited. It's good. So now when you hover over ID, you can just create getter and setter for ID by simply clicking on it and click OK, and it generates the getter and setter for ID. And notice when it is generating the getter and setter for ID, it automatically placed the T in place of the data type. Now we will start creating the objects in the main. And again, it doesn't matter if getters and setters are after main or before main, it'll make no difference. So now when I start declaring objects of generics type, I can say that I want this, in this particular case, the object to be treated as string. Means the property of the object to be treated as a string type, which is T. Wherever the T is, should be string. So now since I said T is string, I will now call the set ID and I'll pass a string value. And let's do a quick test here. Object ID.
So because you put the quotations there, it's going to automatically go to string, correct? Or wait, that's because we declared it as a string
No,
object.
we declared on line 7 it to be a string. That's why it will now require us to pass a string value. But on the contrary, I'm just copy pasting the lines 7 through 9. On the contrary, if I say that I want this to be treated of type integer, then yeah, in object 2 call, the ID is an integer data type. Let me change the value just so that you can see the difference in the output. Everybody caught up?
Yep.
Oh, I didn't pay attention. Even Braden is not here. Okay, so Braden is also missing. Braden and Luke and Alec. Okay. Okay. Now let's create our next class called generics 2. In generics 2, what we will do is we will declare more than one polymorphic type. Means there are 2 types that will be determined during runtime as opposed to one. And there's no limit. You can have 16 types, 20 types, however many. All you need to do is list those many letters. So private TID and private U zip code. So I'll hover over ID and oops. Source, generate getter setters, select all. And generate. So I just generated the getters and the setters for each of the attributes. So now I will declare the objects. And again, just like previous example, you will now list two types. That in this object call, I want the T to be treated as a string because T is the first letter. And U to be treated as an integer because that's the second letter. Okay. Similarly, I can declare another object, like object 2, and switch them around. That in this call, I want the first to be integer and the second to be a string, or both can be integer, whatever it is. It is totally up to you how you want to take care of that. So object 1 dot set ID because it is string. And object 1 dot set zip code because that's a number. And in the second call, I'll change things around.
This is so useful. This is really cool.
All caught up with this example? So I've just given you some basic information about Java generics. Again, you can tap into a little bit more details on your own. Next, we will move on to JCE once I get a go from Sparrow. I think he's still coding. Are there any errors, Sparrow, or you're just coding?
I was just typing it out.
Oh, okay.
I was unfinished with it yet.
Yeah, that's fine. Just want to make sure that you don't have any errors. Okay. Next, I want to go into our next topic, which is JCE, Java Cryptography Extension. So we will look a little bit into how you can encrypt and decrypt the text in JavaScript in Java. Of course, it's very, very detailed topic. It is so detailed topic that if we were to just go in this topic, we'll be working on it for weeks. So again, I mean, like, we're not going to be doing that, of course. So that's why we'll just tap into it a little bit to get started. So our first class will be JCE example number 1. And let me briefly write here. JCE is Java Cryptography Extension. So what it does is it provides framework and implementation for generating key
This is kind of a random question, but are you familiar with Merkle trees at all?
No. So those are the two algorithms that we will use. In our first example, we'll use the DES, which is data encryption standard. And this is the advanced encryption standard. So what do we mean by the word encryption? It is a process of translating plain text into something that appears to be random and meaningless, or in other words, called a ciphertext. And decryption is a process of translating the ciphertext into plain text. So in this example, we'll be working with DES. So when we use the word generating key, it's a framework and implementation for generating key and encryption decryption. So key generation is usually used so that we can hash the value. And based on that hashed value, we can generate encryption and decryption. So that things are so random that nobody can reproduce them on their own, kind of a deal. So this DES encryption and decryption steps. First of all, we need to get a key generator instance. So I'm just labeling so that you can see these 5 steps that I wrote in action. So the step number 1 is to generate a key generator instance. And it will complain that, you know what, I must be placed in a try catch block. So you can hover over and hit surround with try catch. And it'll automatically surround that with the try catch, but that's not I want to do it. I want to rather push this whole thing in a try catch block. I'll write the catches afterwards, okay? Because I'll be writing multiple catches. Let me just create a basic signature. And now I'm going to be filling those in.
For some reason, it is not like auto correcting for key generator. It's leaving the whole line for me just a white text.
Did you import?
Yeah. Maybe I don't know. It doesn't look normal. I think it might be the errors below.
No, that shouldn't affect that line.
It for
Okay, can you share your
Yeah.
screen? Let's see what's going on. Okay,
so ending of main. It's right here. Try catch.
so what is the thing that you're talking about?
It doesn't. It's not changing.
Okay, can you go to generics 2 for me, please? Okay, I see. Okay, now go back to your JC example.
If you want, I can cut this chunk of comment out so we can see it better.
No, apparently maybe it's Eclipse thingy. Let's keep going. Maybe it works fine. Sometimes Eclipse does weird things too.
All right.
Okay. So our step number 1 is to generate the key generator. Step number 2 is to have the secret key. On that key generators of instance. And the secret key will then be used for encryption decryption. In step number 3, I need to get a cipher instance so that I can use the DES algorithm. So I'm using a cipher instance and I am using this particular DES algorithm. Just make sure when you're writing this algorithm, it is CS5. Sometimes people write CSS or C, yeah, because it looks like an S. It's actually a 5. So right now I will be initiating the encryption process using the cipher. So DES cipher, that's the name of my cipher. And I would like to initialize the cipher calling the cipher dot encryption mode using my secret key, which I call my DES key. That's my secret key, which I'll use to cipher the text. So that's basically my initialization of the ciphering process. Now let's get to the text that I want to cipher. So let's create a byte array of plain text. So this line in particular will take the plain text and convert it into a ciphered text. Now we need to decrypt the cipher text. So first of all, we will reopen the cipher, but this time in decryption mode. So was everybody able to encrypt and then get the decrypted text?
Yep.
So this was using the DES approach, which is the data encryption standard. In our next example, we want to use AES approach. Okay, but that will be a slightly detailed example that we will use. So let's create a new class. We're going to call this one My AES app. Public static void main. Finish. Now in the DES, we use a secret key on the key generator, right? But in the AES, we take a slightly different approach. And also I will be using different methods also here. So let me code some methods so that, you know, what we'll be doing. So public static string method to encrypt the text. This will be my encryption method. And then I'll have another similar method that will be called decrypt and will be string to decrypt. So these will be my methods. Again, these errors will go away once I complete the method bodies. But for now, let me write return null, and that will at least take care of the error. Now I will be sharing my key, and I'll be sharing the byte form of the key across methods. So let me declare some global or class level static private static entities. So secret key spec instance, which will be instantiated later on, is shared across the board, and so is the byte key shared across the board. And let me create another method that both of these methods will use. Called set key, because that's where my key will be set. once you guys are done with this code, I'll give you a slight background about these lines so that you understand what's going on here before we get to the encryption decryption. So instead of, like we did in the last example, we had a key generator that generated a key for us. As opposed to having a key generator generate the key for us, I want to be the one who will contribute to the key generator. So I want to have my own key. I will pass that key into the set key to generate my key. And that key will be coming in as a string and will be converted to the bytes. Once it gets converted to the bytes, I will use that string to then figure out how to hash my value. So this basically gives me a slightly, a bit of a control for like coming up with my own key kind of a deal. So what we basically do in this process is we create something called a message digest. So you need to understand a few things before we go to the message digest. So there is a concept of checksum. You guys know what is a checksum?
I do not know.
Okay, so checksum is basically when the data is sent from one end to the other, it just checks to see that the data has not been intercepted. So through the byte mechanism, it tries to figure out if the number of bytes that were sent in the original packet, do they match the number of bytes that are in the receiving packet? So it just does some kind of an error detection mechanism. That's what checksum does. Okay. Then there is another function called a hash function. This is the function that produces the checksum. Okay. And then comes the concept of message digest, which is a fixed sized numeric representation of the contents of the message computed by hash function. So whatever hash function is holding, which is the checksum value, it is a numeric version of that. So in Java, there's a built-in class called message digest, which uses some algorithms like SHA-1 or SHA-256. So we will be using a message digest object as well to help us create the message digest so that we can encrypt our messages. Now that we have created the message digest object, we can now use the message digest object to digest the key, which is currently coming in from line number 14, which is a byte array of string. I purposely only wrote incomplete instruction on line 23. That instruction is actually incomplete. I'll explain to you what that function does, and then I'll complete the instruction. So key is plain text. It's no good. So we give this key to a message digest object called SHA to come up with some kind of a numeric representation of the contents that I've passed. So it will return another key back based on the plain text key. So what I will do is I will change my key with that key. That's basically, so it overrides the previous value of key, which was just a bunch of plain text with a message digest key. Then I will take, and then I will use arrays class to create a copy of the key. And I'll take the 16 byte long key. So we'll have the original, and we have the new length of the key. So now that I've created the key, I can now instantiate my secret key object from line number 10. By passing the key and my encryption algorithm of AES, which is advanced encryption key. So the process itself is a little lengthy because of it being advanced encryption.
I'm sure it's dependent on the situation, but in your experience, would you say one is generally used more than the other, or it just depends?
Say that again.
I said, I'm sure it just depends, but you know, in your experience, would you say that one method is used more than the other, or that it just really depends on the situation?
You're talking about AES versus DES?
Yes.
Oh, DES is older approach. And it's not as secure as AES.
Okay, gotcha.
Now we will start writing the encryption method, in which we will call the set key method, which we declared up there. And as I told you guys earlier, that we will decide what key to generate, and we will give user the power of coming up with something that will help us create the message digest string. So that's why we have the second parameter. This is basically the secret key that we are passing over, which will have, and the user will control it, or a programmer will control it, the logic won't. So you will be able to generate different keys at different time, unlike letting the system come up with something random. And now you will create the cipher for encryption using the AES algorithm. And you will open the cipher using the secret key object we instantiated in the set key method. Now, how do we return that? Is a very lengthy line. So we. So we are grabbing the string to encrypt, which is the first parameter, converting it into bytes from the string, taking it through the ciphering process, and then converting that into a encrypted text through encode to string mechanism, because it needs to return a string. So we are taking that ciphered object and converting it into a string, encode to string method, which comes from the base 64 class. The deciphering or the decryption process is very similar, but not exactly the same. So that's why I'm taking the first 3 lines and only the return part of the 4th line. So let me do this. Let me rather take this whole thing. Okay, it's easier that way. So I'll take the entire try catch block from encryption and paste it in decryption. Then I'll make necessary changes. So we are still setting the key based on the secret passed. We're still creating a cipher text, but now we will be changing it to a decryption mode. And we will not return this. Okay, let me do something different with this example. Instead of having a local main we will actually create a main in a different class so that you can see how secret keys can then be passed. And we can have a better control, but we will wait till everybody is done with this one. Tony, are you done too? Or
Yeah,
you
I'm
still-
sorry. I didn't know you were waiting for
Yeah,
a
okay.
response.
So let's create our next class here. We'll call that one JCE example 2 with a public static void main. In this example, we will come up with a secret key that we will pass. Okay, so that's my secret key, which I'll pass as my second parameter, which will help me generate my secret key. Okay, then let me type the original string. Which is encrypted text. You'll have the decrypted text. String encrypted. My AES app dot encrypt. So the first parameter is the original string. The second parameter is a secret key. So I should expect to get the encrypted text back. Okay. So we'll display a few things. Original text. Encrypted text. So instead of passing original text the second time, I will pass the encrypted text on the same secret key. And now we have the decrypted text. Here we go. So a slightly customizable solution because I can control the secret key. Did everybody get it?
Yep.
Now somebody, I mean, like, let's first look at this one. So we are coming up with our own secret key. We're coming up with our own original message, which we're saying this is the message. Then we're calling the encrypt method in the My AES app. We're passing the original text and the secret key. So here we are passing the original message and the secret key. The secret key is then passed over to set key and is received by my key, which it then uses it to create a message digest. And based on that message digest, it creates a secret key object or secret key spec object. That secret key spec object is then used by the rest of the logic to create an encryption. So we have received a plain secret key, and we have created an encrypted message digest. We have rather, I should say, we have created a message digest on that secret key, and then we are encrypting using that secret key message digest. And then we are using the same one for decryption purpose. If somebody wants to raise the level of their security, what they can do is, instead of creating a plain text secret key, they can actually create a secret key which is encrypted itself and send that encrypted key over. So you can have what we call double digest, double message digest. So first you message digest the key, and then based on that, you generate the next message digest. So you can have a double message digest. So you could actually be storing your entire data as encrypted, and anybody who gets access to that data file will see nothing but ciphertext. And since they won't have access to the secret key, they will not be able to decipher it. And only you know what the secret key is. So when you read that data file, you will then read it through the secret key. Does that make sense?
Yeah, definitely. That's awesome.
Anybody else has any questions? Tony, Sparrow, Luke?
No, that makes a lot of sense. I used to mess with Ethereum contracts, and we used to have to use Merkle trees and sort of hashing our secret keys in order to keep them safe and having our stuff not be taken.
So did you guys like coded those, or like were pre-coded ones?
Yeah, like coding it through Solidity. It's basically the Ethereum blockchain language where you can create contracts and stuff like that. I was just messing with it over the summer.
Oh, cool, nice. So again, as I said, there's lots to dig into in this topic. We only looked at some of the details about this one, not all the details about it. So you can dig deeper into it. Anyway, how about let's take a break here, and then when you come back from the break, we can then look into JAX. What is JAX? Anybody knows? No? So we learn about JCE, correct? What is JCE?
Java cryptography extension.
Right. And JAX is Java API for XML. Or Java API for XML parsing. So we'll look into that. However, let's take a break till 9:50, and then we'll look into that. Hello and welcome back, everybody.
Hello.
So today, as I told you before we went on break, that we'll be tapping into the XML. In order for you to work with XML, you need to work with some parsers, and that's what the JAXP comes, Java API for XML parsers. And I downloaded a parser for you guys already from the internet, which is called the XML exercise parser. You click on this link, and then it will download the parser to your local machine. Don't unzip it, just leave it as a zip file. It's under Unit 6, by the way. It's called XML exercise parser. And let me know when you guys are done with that step. XML exercise parser. Tony, you got it too?
Yes, sir.
Now, next thing what you should do is right click on your project and go to properties. In Java build path, click external, add external jars. And it should be in the downloads for you, and then select that exercise zip file, and then simply apply and close. So I clicked on add external jars.
So libraries, right? Or we just can click class path from the where we
You click the properties, Java build path, libraries, and then you click add external jars, browse that zip file, apply and apply close.
I accidentally added the Java FX ones. I don't understand how I added them so fast. Can I highlight them and remove them?
Yeah, select them and hit the remove button. Have you guys ever worked with any XML documents before?
Mobile device programming we are.
How about the other people?
Just
Yeah, I
in
was a
that.
mobile device over the summer.
Okay. Jessica, you were saying something too?
Yep, just in that class as well.
And Spyro?
A mobile device.
In mobile? Okay, so all of you have, okay. So you know that XML documents are like HTML documents, but none of the tags make any sense because they're all user-defined tags. So that's what the benefit of XML is, that it gives you a structure to your plain text. So what is the benefit of giving a structure to a plain text? Well, there are multiple ways of recording your data. One way to record your data would be to start listing the values that are comma limited. Another way to structure would be to literally create a structure in tags. For example, if I want to store information about students, I can create a structure called class, open and close tag, within which I can create a subtag called student. And for each student, I can create a subtag called first name, last name, and score. And then there is a structure to it. So one of the advantages is to create a structure. The other advantage is that you can do a file to you can do an XML to class mapping. Means you can create a class modeled out after an XML document. So all the innermost values that you want to store, you can create those as class properties, and you can map an object of the class type or an element of an array of the class type to each and every record that you're storing in the XML. So you can do that mapping between Java and XML. So it just streamlines the whole process. So it's all about structuring your content versus leaving them as unstructured or semi-structured text files. Does that make sense?
Kinda.
Kinda?
It's new, so it's setting in.
Okay, okay. So now let's first create an XML document. So let me right-click on the project and create a new. Let me see if it has oh, it has. Okay. You guys also have XML. If you right-click on new and go to other,
No.
you don't have XML.
I don't have that either.
Okay. Okay, if you go to general, you do have untitled text file, right?
Yep.
Okay, let's do that. Untitled text file. And we will then save it as inside the project, whichever is the project level. Okay, I'll call this one students.xml. Okay. I called it students.xml. The first line in the XML document is the encoding. Okay, don't worry about the red lines or stuff like that.
It won't let me name the untitled text file. I'm clicking on source new other
Hold on a second.
general.
Share your screen. Let's see what's going on.
I'm probably just being dumb.
Okay.
So I did source new.
No. Hit finish. Hit finish. Okay. Okay. And now hold on a second. Now click File, Save As. Yeah. Okay. Now choose your project. Scroll down. Yeah, just click on the project. Don't go to the source. Okay, now give it a name, students.xml. Lowercase students s, because the names are case sensitive when we will be using it in Java. XML. Okay. That's it.
Thank you.
Okay. So I have created an XML encoding, and I'm creating a top level tag called class, in which my entire student class will be placed. Each student will be locked inside a student structure. So I'm basically creating a structure. Okay. Every student will have a property or an attribute called student ID, and will have first name, last name, and score. So that's the structure for my XML document. Each and every record will be like that.
I am not. I'm getting errors on my first line.
That's fine. Don't worry about it. This is not important. That if it gives me red lines or not. is just like I want to create an XML document. So then you will copy the structure and paste it 2 more times. So you'll have total of 3 student records. That's what basically we are. That's how we are perceiving it as, that I have 3 student records. And in every student record, I'm going to then add some data. So that creates my XML document and completes it. Okay, let me know when you guys are done. Tony, you're done too?
Yeah, I just finished.
Oh, okay. Luke, Sparrow, and Jessica, you guys are done, right? These are the green check marks. for
Yeah, I'm
now.
good.
Okay. Sparrow, you too, good, right?
Yeah, I'm good.
Okay, cool. So once we have created this XML document, now we'll start using this XML document in Java. So let's now right click to create a Java class called DOM parser demo with a public static void main. So let me first of all tell you that there are 2 parsers that are typically used, or 2 approaches that are typically used from Java to access the XML document. One is called the DOM approach. The other one is called the SAX approach, Simple API for XML. And that's what's explained in this unit as well. So in Java API for XML, which is called JAX, and Java API for XML processing, which is JAX, to work with JAX, you need to have the knowledge of the following technologies. You need to know Java, you need to know XML, and you need to either know the DOM API, which is one of the 2 approaches to communicating with the Java, to the XML document from Java, or the SAX approach, which is Simple API approach for XML. If you're coming in through a SAX approach, you will have your XML document, you'll have your SAX parser and SAX factory, which is what we downloaded from Exersos. And you will now write a Java program, which is called the SAX reader, with 4 methods. The content handler, which is the content inside the tag, the error handler, the document type definition handler, and the entity resolver. You don't have to have all 4 of them, but that's how it works. It just works on these methodologies. It just works on events. On the contrary, you have a DOM handler. A DOM pretty much reads an XML document through a document builder, which comes from Document Builder Factory, and treats the entire XML document like a tree. It'll start reading, for example, in our case, it'll start reading from the class. Then we'll go to the student. From the student, we're going to go to the first name. We'll come back to student. We'll go to the last name, come back to student. We'll read the score, and we'll come back to the student, and we'll then read the next student. So it just reads like a tree. So in our case, it'll just go back and forth. As soon as it hits the end tag, it knows that the student has ended, and it will then search to see if the new student is there to be started. So that's exactly how it will do its job. So in this example, we are taking the DOM parser approach, and probably in the next example, we'll look at the SAX approach. Okay. So I'm building my try-catch block. And the XML file that I want to read is the students.xml. That's the file that we created. And we're using the file object, which comes from the IO package, to load the file in memory. What is the next step in the DOM after you have the file object? You create a document builder factory object, and based on that, you create a document builder object, and then you read that to read the file. So we'll now be working with document builder factory and document builder objects. And they are the ones that come from javax.xml.parsers class. Package. And based on that, we create our document object. Now, this is where it's coming from, that Xerces parser I asked you to download. That's the package where the document is coming from, which will now be parsing the XML document, which is stored inside input file using the document builder. And we now need to normalize it so that we can start reading it. We'll do a quick check to make sure that we can successfully read it. So let's do this. The root element. Doc, which is my document object, dot, get document element. Let's run this.
Did you explain what normalize does?
Just one second. Okay. Yeah, let me get to the normalized part. So what normalized does is pretty much, let me write in the comment section. It puts all text nodes under a node, including attributes. So it basically gives a bit of a structure to XML document so that the Java can start reading. It just brings it in a format that the Java can read. So when you guys are running this line 20, you get the class null also, right?
Yeah.
Because that's our root element in the students.xml. Our root element is class. That's where everything is placed. Now, add one more thing. That I want my document elements node name. Node name. Now rerun it. Now you will just see class. So otherwise it was giving you the entire structure information. Now it gives you just the tag name. How many student tags are there in the class?
There's 3, right?
Yep. So there are more than one. So in that case, we will, in order for us to read that, we need to treat it like an array so that we can read several of them in a cycle. So to treat them as an array, we create a Java collection class called node list. And we will use the dot to get the elements by tag name. And the element I want to read is student element. And since there are multiple student elements, I want to read them in a loop. So that's why I have my loop in place, which is start at 0 and go one less than the length of the node list. Reading one node at a time. So we will now grab from the end list one item at a time. So it will just move one student out of the node list into the node. And let's print this so that you can see student 3 times, just a confirmation. Not that I'm interested in displaying the student tag. It is just a confirmation that it is running 3 times.
Mine says document, document, document.
So again,
Mine says document, 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 like hashtag document.
that's what you're getting for 3 times?
Oh, I used the wrong, yeah, I used the wrong thing. I apologize. It wasn't the node variable I used the doc variable.
Oh,
Yep, it works perfect.
okay, cool. We will just comment out this line because we just wanted to make sure that we can actually tap inside and are able to read this. So now we will take the node object and get the node type, because now we have to start reading inside, right? So we now need to see that when I'm reading inside that node, and if I'm reading another node, because first name is a node, last name is a node, score is a node, then I should actually start going inside by converting a node into an element. And again, I'm picking all the classes that I'm picking are coming from org.w3c. So you can do the same.
Same with the parsers.
Scroll back.
No, never mind.
No, parsers are jacks. So make sure your imports match mine, my imports. Okay, now if I'm interested in reading the score is a number. So let me do this, double score equals to double dot parse double e dot get elements by tag name score, that's the name of the tag. And this is a long syntax. So how about if I break it down into one long line? That'll be easier for you to see what I'm typing. Now let me explain to you why after writing the get element score, we wrote item 0. So you get to this point and you're like, okay, I understand that I'm reading score and I'm reading its content, but what's the point of writing item 0? And here's the point of writing. Let me explain to you like this. What if the person had multiple scores? Because it is possible for you to have multiple score tags inside student ID. In our case, we only have 1 score per student. So generally, Java treats each element like an array. Each element to Java is an array. So we are telling Java that in this array called score, I want you to only read the first item or first occurrence of score. And then grab the content of that. So that will help me grab its content. And then I'm converting that to the double and storing it and displaying it. Similarly, for others, I can say string fname equals to, and I'll do something similar. Except for I don't have to cast it to type double. And here's another mistake sometimes I see students make is they type the first name by copying me, but when they wrote their original XML document, their first name was not all lowercase. If that is the problem, if that's the problem, because it's case sensitive, it will give you an error. So make sure that it matches. So looks like everybody got the output. Did we display everything about the student?
Not their ID number?
Very good. So what is this thing called in markup languages? Attributes. Okay, so we will now display an attribute. So string ID equals to E dot get attribute, and the name of the attribute is SID. Student ID is SID. Oh, sorry, it's ID. And now you can also see the student's ID. Let me know when you guys are done with this.
All done.
Okay, I'm giving you a task in the chat to make some changes to this example. Give me a green check whenever you are done with that. This will change. Okay, so Tony is the only one done so far.
Yeah, I'm still working on it.
Okay,
I think I'm overthinking it.
maybe.
I was overthinking it at first too.
So
I was
I'll
really,
share
really
with you
angry
guys
at
what I
first.
did. So I declared an average and sum, two variables inside the try block. Was the first thing I did. Then I went down inside my loop. And after I read the score, I'm creating a running total. That's the second thing I did. And the third thing I did is when I went outside the loop, I calculated the average. I displayed the sum of the average.
I did that, but put them in the wrong spot. So I think that's where I was struggling.
Okay. Okay, now work on the next thing I wrote in the chat. Oh, Jessica, you already got that thing done? The letter grade for each student?
Nope, I just put that right after the,
Okay.
yeah, sorry.
Maybe, that's fine. So, yeah, give me a check when you guys are done with that step. Okay, everybody got it?
Yep.
Cool. So what I did in my solution is that I created a function called grade, and I passed it a score. And that will calculate a score for me and will return the grade for me, and will return the letter grade back. And then I called it. And I also did one more thing I didn't give you guys, is to also display the average class grade. Everybody did something similar?
Yeah, I didn't create a different class, but the same logic.
Okay, you did not create a separate method, but you use the same logic, okay.
I built mine upside down compared to yours.
Upside down, what do you mean?
So I said if score is less than 60, letter grade is equal to F. Else if score is less than
Oh.
70, letter grade is equal
Oh,
to B.
okay, I mean, like, use a different, okay, conditionals, but same output, okay. How about Luke and Sparrow?
Yeah, I did pretty much the same thing as Jessica, just didn't make another method.
Mine was basically the same thing you did.
Okay, now. You know what? Let me do something different here. We'll put you in breakout rooms. And there'll be 2 people in each breakout room. And we'll put you there for, let's say, come on. For 10 minutes. Okay, let me tell you what I want you to do first. Okay, so display, you'll be changing the display logic, display the entire output. There'll still be a console application though. So let me change maybe to probably 15 minutes, just in case if you need to consult with each other. So that's why you are putting in the breakout room, that you're working individually, but you have somebody to ask. So you will be displaying your final output in columns versus horizontally. It'll be vertical columns. And then you will be displaying the entire data set in vertical columns, okay? And then each column will have its own heading. Send an invite to you guys. Okay, so we have people coming back. Okay, so everybody got it?
Tony and I did.
You guys
I
got
was
it?
able to, I made the headings, but I couldn't figure out how to enter the data into the right spots under the headings.
Okay. Here you go. I also drafted this solution. So what I did, I created these column headings. And I put some dashes underneath them, as you can see in my output, right? And then in my loop, I just simply displayed everything that I was displaying anyway, but using printf, not println, as I did printf over here. And I just put everything in the same spot or same size columns as I had originally declared. And that's all. Jessica and Tony, did you guys take the similar approach?
Exactly.
I'm gonna be honest with you. I was very lost. She helped me all the way through it. Where can I learn this percent sign success stuff?
This is what we're here for. We help each other. It's fine.
Absolutely, absolutely. That was the whole reason of putting you guys in a breakout room. Sparrow and Luke, were you guys using printf or were you taking a different approach?
Yeah, I was using printf, but I just couldn't figure out which values to use for the percent whatever. I couldn't figure out which were the right ones to use because I never really used those.
Okay, so does that make sense what I just did over here?
Yeah.
Sparrow, how about you? Does that make sense to you too?
Yeah, it makes sense. I was going with a similar approach as well. Just couldn't
Okay.
get it to work.
Okay, okay. So guys, today we only started working with the DOM approach. We didn't get a chance to work with the SACS approach. We didn't get a chance to do the object to XML mapping. We didn't get to do XQuery, XPath, XParsers, none of that stuff that originally, I mean, like, this is all part of the XML to Java class. So since we are at the end of the class time here, I removed the assignment from unit 6. I'm going to put that assignment in unit 7, which is about XML and object mapping and things like that. So only one thing you got to take care of during the week. And that would be if you go to the units and unit 6. You just got to do the quiz. That's the only thing you got to do.
Awesome. Thank you, Saad.
No problem. So next week, we will work on the XML and Java again. Most probably that will consume most of the class time. And we may not be able to get to the JDBC Java database connectivity. So most probably we'll be just working with Java and XML next time. Okay. So.
Yep.
Cool. That's all for today then.
Thank you.
Thank you, Saad.
Thanks. See you
Take
next
care.
week.
Saad,
Yes.
just a quick
Mhm.
reminder. I'm sure you remember because
Yep,
you
I
remember-
did.
oh well,
And then-
okay.
Yeah, I do remember, and that's why I just wanted to let you know that, you know, we'll be continuing around the same lines, and we'll be working with SACS and Java next time, and then I'm going to revisit the DOM. And what basically I want to do next is with the DOM is to create a separate class and model the class, structure the class on similar lines as my XML document, and be able to read the data from the XML document directly into a Java object, and then display the object through getters and setters.
Okay,
And
deal.
then-
And then, oh,
and-
sorry, go ahead.
Yeah, and then also be able to see how we can store the XML format data from Java. So Java can create an XML file.
Oh, okay.
Okay, so
Okay.
I said, there's so much to be done. So most probably we'll be staying around Java XML next time. So at least you have the basis and foundation. So when you revisit this, whenever you're back from your big day, and, yeah, again, congratulations in advance.
Thank you so much. Yeah, it's been a long time coming, so I'm very excited. But yeah, and I'll check out the recording too. So thank you for recording those and posting them. That's super helpful.